In 1913, Saniac carried out a simple experiment of passing light in opposite directions around a table and recombining them. This produced interference fringes. He then rotated the whole table at 2 revolutions per second and found that the fringes changed. This result has very significant implications in science. It works as follows. A beam of light leaves the light source at the bottom left-hand corner and is split into 2 different beams, which we have coloured red and blue just to distinguish them. They travel round the circuit in opposite directions until they eventually reach the splitter, which also recombines them. There they then go on to the photographic plate, where they have interference fringes. In this simplified version, we see that the beam is split into 2, the red and the blue again, and they go round the circuit and are recombined at the splitter and recombining prism, so that they again produce the fringes on the photographic plate. Now let us rotate the table. Before we do so, there is the very important subject of the effect of the ether. The Michelson-Morley experiment failed to detect the 30 kilometers per second motion of the Earth through the ether. So as to overcome this problem, Einstein simply abolished the ether in his relativity theory. The very significant result of the Sagnac experiment was that it proved that the ether existed. Let us see how it did this. It is a fundamental feature of relativity that it claims that as there is no ether, light travels away from a source at the same speed relative to the source, whether the source is moving or not. Thus, whether the table is turning or not, the fringe patterns should stay the same. But if the ether exists, once the light has left the source, the speed of the light is controlled by the ether, independent of the speed of the table, mirrors, etc., as we see here. So let us see what happens when we rotate the table. Here, the light is split, and the red and blue lights go in opposite directions. But notice that the left-hand mirror has moved around in such a direction that the distance the red light has to travel is further. Now in relativity, the same time should be taken because the splitter is also moving and the distance between them is the same. But now imagine that the ether exists and the speed of the light is controlled by the stationary ether. Imagine the ether like a thick treacle that limits how fast the light can travel, independent of the motion of the light source, the splitter, or the mirrors. The result is that the red light takes longer to reach the left-hand mirror. Similarly, the right-hand mirror is coming towards the blue light, so it reaches the mirror quicker. After they change ends, the red light again takes longer to reach the recombiner, whilst the blue light gets there quicker again. So they reach the photographic plate with a delay between them, and this changes the fringe pattern. In fact, Sagnac, using the speed of the rotation of the table, calculated how much the fringes should change, and found that they did change by just that amount. The crucial feature of this experiment is that it demonstrates that the ether does exist, which demolishes relativity. How does the scientific establishment deal with this result? By muddying the waters with scientific gobbledygook. Wikipedia says, in the above discussion, the rotation mentioned is a rotation with respect to an inertial reference frame. Since this experiment does not involve a relativistic velocity, the same wording is valid both in the context of classical electrodynamics and special relativity. How on earth can it be valid in both theories? It clearly proves that the ether exists because the speed of the light is controlled by the ether, independent of the rotating table and mirrors. This experiment is never taught to university science students. They might begin to question what they were being taught about the cosmos, the universe, the Big Bang, evolution, and much else.